Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 4, which is a mechanics for October-November 2023, and the code is 9709/42. So let's move on to question number 1. For question number 1, a block of mass 15 kilograms slides down a line of greater slope of an inclined plane. The top of the plane is a vertical height of 1.6 meters above the level of the bottom of the plane. Now then the speed of the block at the top of the plane is 2 meters per second, and the speed of the block at the bottom of the plane is 4 meters per second. Now find the work done against the resistance to motion of the block. Okay, so now let's say this is the diagram. So slides down, that means this is a block. Alright, so initially it is 1.6 meters above the bottom of the plane, and then the speed of the block at the top of the plane is 2. So this is u equals to 2 meters per second, and when it reaches the bottom, okay, so the v is 4 meters per second. And then now it's mentioned that the m is 15 kg. Okay, so from here, I will have the weight of 15 g. Okay, so these are the information given in the question. Now, what I need to do here is, because the question mentioned that you need to calculate work done against the resistance to the motion. So here I will be using the total work done. Okay, this is the work energy principle. So work energy principle that means total work done equals to increase in mechanical energy. Okay, so for your information, total work done is basically work done to speed up the body minus work done against the resistance. Okay, then increase in mechanical energy means that it is increase in kinetic energy. So probably I will just write KE, right? It will be easier. Plus increase in gravitational potential energy. Okay, so now for your information, in this question, there is no work done to speed up the body. So that means it will be 0 minus work done against resistance. Then now increase in kinetic energy is basically the final KE. This is basically final KE minus initial KE. Okay. Same goes to the increase in PE. This is the final PE minus initial PE. Okay, so now for your information, the kinetic energy is basically half mv squared or mu squared. Then the PE, okay, the gravitational potential energy is mgh. Alright, so now from here, I will just direct solve. This is going to be half. Okay, final KE means that it is half mv squared. The m is 15 kilograms. So it is 15. Alright, so the v is basically 4. So 4 squared. Then minus half 15, then u squared is 2. Or I'm sorry, u is 2. So u squared is 2 squared. That is the increase in KE. Okay, now plus increase in PE. So initially, alright, it is at the height of 1.6 meters. So this is the h. Alright, so our mg will be 15g, then together with this h. So I will write it will be 15g, g is 10. Okay, then the h is 1.6. And then now, the initial PE, it is at the bottom. Alright, sorry. Final PE is 0, okay? Because that is the initial height. So final PE is 0 because it is at the bottom. So then I will write 0, then minus mgh 1.6. Alright, so that's the working for this. And then now for the left hand side, I will get minus work done against resistance. It will be, alright, so when I calculate the first brackets here, it will be 90. Okay, then plus the second bracket is going to be negative 240. Okay, then from here, you will be getting negative 150. So then, now since the question is asking for work done against the resistance, and I have a negative here, okay, and this is also negative, so the negative can be cancelled off. At last, I will be getting the answer as work done against resistance equals to 150 joule. Okay, so this is the working for question number 1. Okay, now question number 2. So now the diagram shows a smooth ring R of mass mkg. Okay, it's given or is labeled in the diagram, threaded on a light and inextensible string. The horizontal force of magnitude 2 newtons acts on R. The ends of the string are attached to fixed points A and B on the vertical wall. The parts AB of the string makes an angle of 30 degrees with the horizontal, and the parts BR makes an angle of 40 degrees with the vertical, and the string is taut. The ring is in equilibrium. So this is the key word. Equilibrium means that the ring is static, is not moving. Find the tension in the string, that is the first part, and the value of M, this is the second part. Okay, so from here, since same string attached to the A and attached to B, that means I will have the T here. Okay, the tension of the string. Now, from here, since this is equilibrium, that means it is not moving. So now I need to resolve the forces vertically and horizontally. Alright, so if I resolve vertically, okay, let's say, right, or I resolve horizontally first. You have to consider these two. So if I resolve horizontally, that means I'm resolving this T to this direction, and the AR, the TAR, right, moving down or resolving down. So for your information, I need these two angles, but these two angles are not given. So I'm going to use the 30 and 40 degrees. So if you are using the alternate angles, that means it will be sine. Okay, so once I've resolved these two t's, it will be in the opposite direction of the 2n. So since the F equals to ma, the a is 0, that means I can just say the forces of the t is balanced by the 2n, right? So now from here, I will just write down, I resolve vertically, horizontally, okay? So the t sine 30, because I use this angle, plus t sine 40 degrees, it will be 2, okay, because it's balanced. So here it will be t sine 30 degrees plus t sine 40 degrees equals to 2. Okay, so when you calculate this, the left hand side, the sum of the two t's, you will be getting 1.142788 t equals to 2. So then from here, my t is going to be 2 divided by the whole value. So here I write down the exact value. Then final answer, I round up to 3 significant figures. That will be 1.75 Newton. So when you resolve horizontally, you can easily find the tension. Okay, so now for the m, to get the m here, I will resolve the t vertically. Right. So when I resolve vertically, you see here, this is 30 degrees, 40 degrees. That means according to the angle's properties, this is also 40 degrees. Okay, here is also 40 degrees. Then same goes to this part. This is going to be 30 degrees. Alright. So here is 30 degrees. This is 40 degrees. Okay, so now I resolve both. Then when I resolve, this T is going up, right? And then the BR, the tension at the BR is pointing down, because you see the arrow of our T here. So going down, and this going down is same direction as the weight. That means it's mg. Alright, so that means now when you resolve vertically, okay, so you have to consider both cases. So the first one is t cos 30. This is t cos 30. Okay. Then the bottom one, which is towards pointing up downwards, it is mg. That is the first. And then another one is this t. So this t you resolve, that will be t cos 40 degrees. So that means these two are balanced. So now I will be getting t cos 30 degrees equals to t cos 40 degrees plus the mg. So t cos 40 degrees plus mg. Okay, so since we have found the t just now, alright, so then from here I would say my mg, or my t cos 30 degrees minus t cos 40 degrees equals to mg. The g is replaced by 10, so therefore 10m. Okay, then from here I would say my m is basically the t 1.75 cos 30 degrees minus 1.75 cos 40 degrees, then over 10. Okay, then from here you will be getting 0.017497. So when I round up to 3 significant figures, that is going to be 0.0175. So that's the solution of this question 2. Okay, so now next question number 3. A block of mass 10 kilograms is at rest on a rough plane, right, inclined at an angle of 30 degrees to the horizontal. So here is a 30 degrees. A force of 120 newtons is applied to the block at an angle of 20 degrees above the line of greatest slope. So here is 20 degrees, 120 newtons. There is a force resisting the motion of the block, and 200 joule of work is done against this force. So this is the work done against the resistance. Alright, so then now when the block has moved a distance of 5 meters up the plane from the rest, so it means that here 5 meters. Alright, then you will have the work done against the resistance. Right, so now find the speed of the block when it has moved a distance of 5 meters up a plane from rest. So from rest, we know that at first u equals to 0. Then now you need to find what is the speed here. Okay, and then we know that this is mg, so 10g. Alright, and it is given that this is the rough plane. So the block is moving up, therefore the resistance is moving down, right? Pointing down. So this is your FR. Okay, now here I will have the R here, the normal force. Now to get the speed of the block, since you are given this sentence, work done against the force, alright? That means this is the work done against the resistance. Okay, so again, to solve this question, I will use the work energy principle. Alright, so from here, I will just write my work energy principle. Okay, so total, or I will say work done to speed up the body minus work done against the resistance it is same as final KE minus initial KE. KE is a kinetic energy plus final PE minus initial PE. Okay, so from here, this 200 is to against the work done, to against the resistance. Now I need to find out what is the work done to speed up the body. Okay, so here, look at this, 120 newtons. This 120 newtons is the extra force. Alright, so that means this is the force to speed up the body. So now I have to resolve, because the work done basically is F times D. Okay, work done, this work done is F times D. So the F is the force and then the D is the distance. This force must be parallel to the distance. Alright, so that means I have to resolve this force so that it is parallel to the plane, because it is 5 meters. Right, the block has traveled 5 meters. Alright, so you have to resolve so that it will be parallel to the plane. Okay, so when I resolve, this is basically using the given angle. Therefore, my F, it will be 120 cos 20 degrees. Okay, that is my F. And then my D is 5. So here, I will write 120 cos 20 degrees. This is my force. Then I times 5. Okay, that is the work done to speed up the body. Then minus the work done against resistance is given here, 200 joule. So this is 200. Okay, then final KE. Final KE means that the block has reaches 5 meters, has traveled 5 meters. Okay, so now the V is unknown. So for your information, the kinetic energy formula is half mv squared. I have introduced just now. Okay, KE is half mv squared, and then the PE is mgh. That means now here I will be writing half, my m is 10. Alright, m is 10, this is the m. The v squared, we do not know what is a v. Then minus half m, what is my initial u? Okay, it's mentioned here. U is 0. Alright, because it is from rest. If you refer to the question over here. Alright, therefore, it will be 0 squared. Then plus, okay, this is for the increase in KE. Final PE. So for final PE, I need to find out what is my height here. Vertical height. This is my h. Alright, so now, for your information, okay, so since the block is starting here, so I will not count until the bottom of the plane. So my h is over here. So this is 30 degrees. That means here is 30 degrees. Right, so now I'm resolving this 5 meters using the, okay, I'm resolving, I need to go up, alright, or probably from here you can just say, this is the opposite side, this is the edges, hypotenuse. So opposite and hypotenuse is a sine. So sine 30 is h over 5. So h will be 5 sine 30 degrees. Okay, because I'm resolving this up vertically. Alright, so then I will write half, mg, so mgh, so m is 10, g is 10, then the h here is basically 5 sine 30 degrees. So here is going to be 5 sine 30 degrees, and then now initial PE. Okay, so I treat this as the initial length, initial level. Therefore, the height will be 0. So then here will be 0. Okay, so then from here, we are able to find the V. So for the left-hand side first term, when you calculate, it will be 563.8156, then minus 200 equals to, now when you calculate this, okay, the first one or the second one will be 0 because of the 0 squared. So this one will be 5v squared. Right, the first term on the right side is 5v squared, and then you calculate the first term on the second bracket on the right side, it will be plus 250. So from here, okay, I will just move all the terms to the other side and calculate how much is that. So then I will be getting 5v squared, it will be 563.8156 minus 200 minus 250. Then you will be getting 113.8156. Then now, the v squared, you just divide by 5. So 113.8156 divided by 5, you will be getting 22.76312. So then your v is square root of the value. Therefore, you will be getting 4.77 meter per second. So that is your v, okay, the speed of the block. Okay, now next question, number 4. A particle P of mass 0.2 kilogram lies at rest. At rest means U equals to 0 on a rough horizontal plane. A horizontal force of 1.2 newtons is applied to P. A, given P is in limiting equilibrium. Okay. Find the coefficient of friction between P and P and the plane. So let's say this is the diagram. Alright, this is the P. So here you have 1.2 Newton. So means the P is moving to the right side. Okay, then the mass is 0.2 kg. So the weight is 0.2 g. And same goes to the reaction force. Okay, the normal force, I would say normal force. And then it's mentioned that it is a rough plane. So when rough plane, right, then you will have frictional force. So this frictional force is Fr, which is mu r. Okay, so now it is in the limiting equilibrium, means that the particle is not moving yet. Right, it's just about to move. So from here, I will say my r is 0.2 g, which is 0.2 times 10, which is 2. Okay, and then now you use F equals to ma. So when it is at rest, u equals to 0. So when u equals to 0, definitely your a will be 0. Alright, because no speed, therefore no acceleration. So now from here, the particle is moving to right side. Okay, it's about to move to the right side. So it will be 1.2 minus the Fr. Fr will be mu r. So mu r is 2. Then equals to the 0.2 times 0, because ma is 0. Then from here, you will be getting 1.2 minus 2 mu equals to 0. So 2 mu is 1.2. Therefore, your mu is 1.2 divided by 2, which is 0.6. So done for this mu, coefficient of friction. Now B, given instead the coefficient of friction between P and the plane is 0.3, it's not 0.6. Now find the distance traveled by P in the third second of its motion. Okay, the keyword is here, third second. Alright, so now when mu equals to 0.3, okay, so now I will use F equals to ma. Okay, now your friction, your particle is moving, right? So then using the same diagram here, so I will use back this equation, okay, but I change my 0 to a, and then I change my mu to 0.3. Okay, the rest remain. So here I will write 1.2 minus 0.3. My r still the same because it's the same particle, which is 2, equals to 0.2, which is my m. Then my a is unknown. Okay, because we do not know what is the a now. Then now, sorry, this is 2. Okay, then from here, left hand side, when you calculate, it will be 0.6. Right hand side will be 0.2a. Then from here, my a is 0.6 divided by 0.2, which is 3. So now you need to find the distance. Okay, travel in the third second. So travel in the third second means that, let's say this is t equals to 0, 1, 2, 3. So you need to find the distance traveled in the third seconds, means that you have to find S3 minus S2. Okay, that will be the distance traveled in the third second. Alright, so now to get that, I have to find S3 equals to UT plus half AT cubed. So that means this is when T equals to 3. Okay, so initially the U is 0. Okay, go back to the A. So initially U is 0. That means the U equals to 0 here. Then the T is replaced by 3 plus half A. A already found 3. Then the T is also 3. So 3 cubed. Then from here you will be getting 27 over 2, which is 13.5 meters. Now, the distance traveled for the first 2 seconds, when t equals to 2, so I'm getting S2. Use back the same formula. Sorry, this is half AT squared. Okay, then it will be, again, U is 0, T is 2, plus half A is 3, T is 2 squared. Then from here, you will be getting 6 meters. Alright, so now the distance traveled in the third in the third second, it will be S3 minus S2. Okay, then from here, I will be getting 13.5 meters minus 6 meters, that is 7.5 meters. So that is the solution of this question. Okay, now question number 5. A particle A of mass 0.5 kilograms is projected vertically upwards from the horizontal ground with speed 25 meters per second. A. Find the speed of A when it reaches a height of 20 meters above the ground. Okay, let's say for example, this is the particle. You project upwards. The U is 25 meters per second. Okay, and then this is M equals to 0.5 kg. Now you need to find the speed. What is the V? Okay, when it reaches here. This is 20 meters. What is the V over here? So for this case, I can just use V squared equals to U squared plus 2AS. Okay, then from here, the V is unknown. The speed of A when it reaches 20 meters is the V. So the U is 25, then you square it, plus 2A. Okay, the A is minus 10 because it is projected upwards. So it is against the gravitational acceleration. Then the S will be 20 meters. Then from here, you will be getting 225. And at last, your V is square root of 225, which is 15 meters per second. So that's the solution for 5A. Now, when A reaches the height of 20 meters, it collides with a particle B of mass 0.3 kg, which is moving downwards in the same vertical line as A with speed 32.5 meters per second. So this is the UB. Okay, this is the UB. In the collision between two particles, B is brought to instantaneous rest, means that VB is 0. Now B, show that the velocity of A immediately after the collision is 4.5 meters per second downwards. Alright, so now that means, okay, the diagram becomes this. So initially, the A is here. Right, this is the A. Once it reaches 20 meters, it collides with the B. Right, so let's say for example, B is here. So then the B reaches here. Okay, maybe I use different color. Then the A. Alright, so then now the UB is this one going down, this one going up. So the UB is 32.5. Okay, then the UA just now, UA 25. UA is 25. Here is 25. Okay, now just now we have found when it reaches to 20 meters, the V is 15. Okay, that means now here VA equals to 15. Alright, and now you need to show that the velocity of A immediately after the collision is 4.5 meter per second downwards. You want to show that. Okay, basically, after collides, the VA is this. Okay, you want to show V1. Probably this is V1. V1A is 4.5. This is what you need to show. Okay, so from here, what we do here is, since collision involved, that means I will refer to the linear momentum. Okay, I will refer to the linear momentum. Now, I will say we consider upwards. So, MA, right, VA here, MA, VA, plus MB, UB equals to MA, V1A, or V prime A, okay, V prime A. So, means that I will label here as V prime A. Right, then plus MB, VB. So it's mentioned that the VB is 0. So here, VB equals to 0. Alright, so now just replace all the values. Your MA is 0.5 kg. So MA 0.5 kg. MB is 0.3 kg. So here it will be 0.5. The VA here is 15. Okay, because we need to consider this situation here. Alright, so then the MB will be 0.3, then the UB is 32.5. But then now you see I'm considering upwards. Okay, so this UB becomes negative because it is downwards. So be careful with this. That equals to MA is 0.5, VA prime, we have no idea what is that, then plus MB is 0.3, but then VB is 0. Okay, so now the left hand side first term is going to be 7.5, second term is 9.75, then right hand side is just 0.5 VA prime. Okay, because last term is 0, this is 0. Then now I will be getting 0.5 VA prime is negative 2.25. Therefore, VA prime is negative 2.25 divided by 0.5, and you will be getting negative 4.5 meter per second. Now, look at here. I consider upwards as positive, and now you are getting negative. So this negative is to show that this is downwards. Okay, so is the direction of the movement or of the motion. So then from here, I would just say VA is 4.5 meter per second, VA prime, okay, downwards. So that's the solution of this question. Okay, now see, find the time interval between A and B reaching the ground. You should assume A does not bounce when it reaches the ground. Okay, so now here, to get the time interval, so I consider downwards for the particle A. Okay, so S equals to UTA plus half ATA squared. Right, now I need to find out, okay, so time interval, that means now the particle, this particle A will move down, okay, what is the time, and what is the time for the B to move down, okay, so what is the time for the B to move down here, so this is TB, this is TA, okay, so then now I will just write this is 20 meter per second. Oh, sorry, 20 meters because the A has traveled for 20 meters. This is the 20 meters. Alright, after the collision. So then from here, I will just write the U is 4.5 because I'm considering after the collision. Then TA plus half, the A is 10. Okay, then TA squared. So when you simplify this, this is basically 20 equals to 4.5 TA plus 5 TA squared. This is my equation. Okay, so from here, basically I can just solve what is the TA squared here. So then, because of the 4.5, I don't want to have fraction or decimal, so I times 2. So when you times 2, right, you will get 40 equals to 9 TA plus 10 TA squared. And now I rearrange this to get the TA. So 10 TA squared plus 9 TA minus 40 equals to 0. Then from here, you can factorize this into two linear factors. 5TA minus 8 times 2TA plus 5 equals to 0. That means your TA equals to 8 over 5 or TA equals to negative 5 over 2. So we know that time cannot be negative. So time must be positive. Therefore, TA equals to 8 over 5, which is 1.6 seconds. Okay, so A took 1.6 seconds to reach the ground. Now for the B. So I consider downwards for the B. Okay, so now look at here. When it collides, right, I will not consider this time. I will consider when the B, right, because we are considering the after the collision. So what is the TB here? Right, that means the S is still 20. Okay, it's not from the beginning. So we are considering the second half of the motion. So using the same formula, right, S equals to UTB plus half ATB squared. So 20 equals to U is 0 because we are considering this motion. Okay, we are considering this motion. So this is your U for the B now, which is 0. Okay, then T is TB plus half. Again, the A is 10, then TB squared. Then from here, you will be getting the TB. So which means 20 is 5 TB squared. So TB squared is 20 over 5, which is 4. Therefore, TB is square root of 4, which is 2 seconds. Okay, so means that B needs 2 seconds to reach the ground, whereby A needs 1.6 seconds to reach the ground. So now the question asking for time interval between A and B reaching the ground. That means now we just need to minus. So time interval equals to 2 minus 1.6 seconds, which is 0.4 seconds. Okay, so that's the solution of this question. Now question number 6. A railway engine of mass 120,000 kg is towing a coach of mass 60,000 kg up a straight track inclined at an angle of alpha to the horizontal where sine alpha is 0.02. Now there is a light rigid coupling parallel to the track connecting the engine and coach. The driving force produced by the engine is 125,000 newtons, and there are constant resistances to the motion of 22,000 newtons on the engine and 13,000 newtons on the coach. That means all these are the frictional force. Okay, so now here, A, find the acceleration of the engine and the tension in the coupling. Okay, now what to do here is probably I will just draw this diagram. This is the alpha. right? Given sine alpha is 0.02. Okay, then here, right? Okay, then here you will have driving force. This is the engine. Driving force. Driving force is 125,000 newtons. Okay, then this is the T, tension. Okay, then here at the same time you also have the resistance, 22,000 newton. So this is 22,000 newton. Let's say this is the engine. Alright, and then this is the coach, so FC. And then for the engine, you will have mass of 120,000 kilograms. So the weight just times the G there. So for the coach, it is 60,000. So it is 60,000 G. Okay, so this is the diagram. Now you need to find what is your A and also the T. Okay, so from here, I will just use F equals to MA. I consider the system, right? So F equals to MA, the Newton's second law. I consider the whole system. So when I consider the whole system, right, what I'm getting is I consider all the forces except the T, because both T will be balanced back, right? That's why I consider the system, that I can find the A directly. So first of all, I will have going up, okay, 125,000, that is the force, okay, going up, and then I got to minus this, minus resolving this weight, okay, minus resolving this weight. So now here is alpha, that means I'm using alpha value to resolve, so therefore it's sine. So I will have to write minus 120,000 G sine alpha. Okay, then I have a minus a FE. What is your FE? Okay, so from here I will write FE, it is 22,000. And then the FC is 13,000. So I minus the FE first. So the FE is 22,000. Then I resolve the weight of the coach, which is 60,000 G sine alpha. Okay, because all these are in the opposite direction of the D. Then I minus the FC, 13,000. Alright, so then now equals to MA. Now my M, the whole system, my M is basically the mass from the engine and also from the coach. Therefore, this is going to be 60,000 plus 120,000. Okay, that is my M. Let's say I write it next line. Then it will be 120,000 plus 60,000. That is my M. And then just let it be A for the acceleration. So this is how we get the equation when you consider the whole system. Now, when I replace the values 125,000 minus 120,000 times the G is 10, sine alpha is given here. Sine alpha 0.02. Then now you replace it by 0.02. Then minus 22,000 minus 60,000 times the G is replaced by 10. Again 0.02. Then minus 13,000. Okay. Then right hand side, 120,000 plus 60,000, you will get 180,000. A. So for the left hand side, when you calculate all these terms, right, it will be 54,000. Then equals to 180,000 A. So now from here, I can cancel off the 000. So now basically my A is 54 over 180. Therefore, you are getting 3 over 10, which is 0.3. That is your A. Okay. Now, to find the tension, you have to refer to either the engine or the coach. So I will just consider the engine, which means I will consider this part. Alright, so now you can consider the coach as well. So when I consider engine, again F equals to MA. So for engine, I will refer to D, the 120,000, and also the FE. So which means I will just copy the working from the previous part up to here. Okay, and don't forget, I still have one more, which is the T. Right, the T is also in the opposite direction of the D, so I just add on the D there and I copy the rest. So then I will be getting 125,000 minus 120,000 G sine alpha, then minus T minus 22,000. Okay, now my M is just 120,000, then times the A that I found, 0.3. Then from here, you will be getting 125,000 minus, right, all these values, and then 0.02. The T is unknown, then minus 22,000, that equals to 36,000. Then now my T, just move the T to the left side and this 36,000 to the right side. Then you will be getting 125,000 minus 24,000 minus 22,000 minus 36,000. Then from here you will be getting 43,000 Newton. Okay, so this is how you consider the engine to get the T. So if you don't want to consider the system, you can consider the engine and also the coach using the same method. Okay, so done for this part. At an instant when the engine is traveling at 30 meters per second, it comes to a section of track inclined upwards at an angle beta to the horizontal. The power produced by the engine is now 4,000 or 4 million. Okay, or I will say that it is 4,500,000. 4.5 million, okay, I will say 4.5 million watts, and as a result, the engine remains at constant speed. B, assuming the resistance forces remain unchanged, find the value of B. Okay, so now the question is similar to just now. It's just that now, okay, instead of alpha, this is beta. Then this is the engine, and then this is the coach. Okay, so then here you still have T. So here I use the T prime. Right? Then this is a driving force. So now it's mentioned that constant speed. So when constant speed, so go back to the previous. Okay, traveling at 30. So now your D, U is 30 meter per second. A equals to 0 because of constant speed. Then here I still have the FE, and then this is the FC. Then together with the weight, this is 60,000. Okay, so I need to find what is my beta. So what to do here is, right, we need to calculate the beta. So then first of all, we need to get the driving force because now you are given the power. So then power equals to driving force times V. So 4,500,000, 4.5 million equals to d times 30. Therefore, your d is, okay, now I cancel the 0 from both sides. So it's basically 4.5, all these values divided by 3. You will be getting 150,000. So now again, I consider the whole system to get the B, the beta, right? So system, again, F equals to MA. So then the D becomes same method as just now. Just replace a D, okay, and change the alpha to beta now. So G sine beta minus 22,000, because your FE and FC remains, right? Minus 60,000 G sine beta. Then the FC just now was 13,000. That equals to, it will be 180,000 times 0 because of constant speed. Then from here, you will be getting 150,000 minus this amount times 10 sine beta minus 22,000 minus 60,000 times 10 times sine beta minus 13,000 equals to 0. Okay, then from here, I will group the sine beta together. So these two terms will be moved to the other side. That means I will be getting the rest. You will be getting 150,000 minus 22,000 minus 13,000 equals to, this will be 1, 2, okay, total of these two, alright? Or probably I just do step by step. 120,000 times another 0 sine beta plus 60,000 times another 0 sine beta. So the left hand side you will be getting 115,000. The right hand side it will be 18, 1, 2, 3, 4, 5. There will be 5 zeros here. Alright, so from here I will get sine beta. You can just cancel the 0 from both sides. Then it will be 115 over 1800. Then at last you will be getting 23 over 360. So your beta is inverse sine. That is going to be 3.66 degrees. And now angle in degrees must be correct to 1 decimal place. That is 3.7 degrees. Okay, so that's all for this solution. So again, the alternative method to solve this question is you consider the coach and engine. Right? Now, next question, number 7. A particle x travels in a straight line, and this is the velocity. Now, the acceleration of x is 0 at t equals to p and t equals to q, where p is less than q. Find the p and q. So this is the acceleration. So we know that acceleration is dv over dt. Means now I need to differentiate the v. Okay, so when you differentiate, it will be negative 0.3 t squared, then plus 3.6 t minus 6. Alright, so then it's mentioned that the acceleration is 0 at t equals to p and q. Okay, therefore, from here, I will let a be 0. So 0 is negative 0.3 t squared plus 3.6 t minus 6. Now to eliminate the decimal, I times negative 10 because I need to get positive t squared. So you will be getting 0 is 3t squared minus 36t plus 60. Okay, so and then this can be divided by 3. So when divided by 3, it will be 0 equals to t squared minus 12t plus 20. And this quadratic can be factorized into two linear factors, t minus 10 and t minus 2. Okay, therefore, the product of these two terms equals to 0 means one of them must be 0, which means either t minus 10 equals to 0, which means your t is 10, or t minus 2 equals to 0, that means your t is 2. So it's mentioned that your p is less than q. Okay, so p is less than q, therefore the p is 2 and the q is 10. So that's the solution of this question. Okay, now it's given that the velocity of x is 0 at t equals to 14. Find the velocity of x at t equals to p and t equals to q, and hence sketch the velocity time graph for the time from 0 to 15. Okay, so now when t equals to 2, okay, I need to find out the time when t equals to 2 and t equals to 10 first. So when t equals to 2, the v is, just refer back to the v here, just substitute the t equals to 2 into this expression. So minus 0.1 t cubed plus 1.8 t squared minus 6t plus 5.6. So plus 1.8 t squared minus 6t plus 5.6. This is 0. So when t equals to 10, that is at the q. So your v, use the same method. Just replace the 2 by 10. Then this is going to be 25.6. Okay, now we know that velocity at t equals to 14 is 0. But then what about 15? So we need to count when t equals to 15. So the v is negative 0.1, 15 cubed plus 1.8 times 15 squared minus 6 times 15 plus 5.6. Then this is going to be negative 16.9. Okay, and at the same time when t equals to 0, when t is 0, your v is first term 0, second term 0, third term 0, so means 5.6. So here I get another value, t equals to 14, my v is 0 as well. It's mentioned in the question. And now to sketch a graph from 0 to 15. Okay, so by referring to all these values, right? So just draw the axis first. My v has negative value and the positive value maximum is 25.6. Okay, so probably 5, 10, 15, 20, 25, and here is 30. Then here 5, 10, 15, negative 20. Okay, then my t will be 0 to 15. So let's say here 2, 4, 6, 8, 10, 12, 14, 16. This is my t. Okay, here is my v. Right. So then now, when t equals to 0, v is 5.6. 0, 5.6. So let's say here. When t equals to 14, v is 0. Okay, it's 2 done. When t equals to 2, 0. When t equals to 10, 25.6. So 10, 25.6. 25.6 is roughly here. Okay, then the other one, when 15, t is 15, the v is negative 16.9. 15, negative 16.9, roughly here. Okay, so since this is cubic function, you see the t cube here, t cube, right? So it will be in this shape because of negative t cube. Okay, so now I will join the points. Alright, so this is my v equals to negative 0.1 t cube plus 1.8 t squared minus 60 plus 5.6. So done for the graph. Okay, now part C. Find the total distance traveled by x from t equals to 0 and t equals to 15. Okay, so the total distance is basically the area under the curve. Alright, so now we need to integrate the v with respect to t, and then here we have to split it into two integrations, because for your information, the area under the curve from 0 to 2 is positive because it's above the x-axis. Same goes to 2 to 14, but for the 14 to 15, this is 15. Okay, we need to put the modulus because the region is below the x-axis. Alright, so basically I need to do two integrations. Okay, so now I will just write my distance as equals to integrate from 0 to 14 the v. So negative 0.1 t cubed plus 1.8 t squared minus 60 plus 5.6 dt. This is my v. And then I have to plus with the modulus from integration from 14 to 15 because this region will be negative. Or I would say the region is below the x-axis, therefore your integration is negative. So it is compulsory to put the modulus to make sure that it is positive there. So then here I will integrate. So negative 0.1 t cubed becomes t4 over 4 plus 1.8 t squared becomes t cubed, that over 3 minus 6t squared over 2 plus 5.6 t. Then limits from 0 to 14. Same goes with the other one, just copy this integration. Okay, then from here, when you simplify, this negative 0.1 over 4 is basically negative 0.025. Then now I directly replace the t by 14. So 1.8 divided by 3 is 0.6. Then here 14 to the power of 3. 6 divided by 2 is 3. So 14 squared plus 5.6 times 14, then minus 0. This is my first calculation. And then now for the next one, remember to put a modulus. Okay, so negative 0.025, replace the t by 15 first. So just refer to the first calculation here. Alright, replace the 14 by 15. The rest remain. Okay, then I have to minus all the rest. Okay, minus the same value, but it will be this value. All this, I will have to minus this because you have to replace the t by lower limits, which is 14. So I will just rewrite. So negative 0.025 times 14 degree 4. Okay, plus 0.6 14 degree 3 minus 3 times 14 squared plus 5.6 times 14. Alright, so this is what I get. So now when you calculate the first square bracket, it will be 176.4. Okay, plus modulus, the whole modulus, it will be negative 8.025. So then from here, to get the distance, the modulus of negative, it will be positive. Okay, so add up these two values, you will be getting 184.425, and then round up to 3 significant figures. At last, you are getting 184 meters. So that is how we calculate the total distance, right? Which is area under the curve. That's why the graph is very important. When you need to integrate, make sure the value, the region is above the x-axis, right? Otherwise, you have to put a modulus, just like from 14 to 15, the t. So the region is below the x-axis, below the t-axis. Therefore, we have to put the modulus for the integration, which is shown here. Okay, so we have completed the whole paper and also comes to the end of the video. Thanks for watching. Please subscribe to the channel and like the video, and also share it to your friends if you enjoy watching my videos. Now, and stay tuned for more academic videos. Thank you. Bye.